Thank you for joining us today. I'm Brian DeLuca along with Nicolette Amino, and we will be the host of this live chat for you. Advancements in battery technology and battery chargers accelerate automation and unlock creativity. This is a live chat, everyone, so make sure you're asking questions in the Q&A at the bottom of your screen. Now I'm going to pass it over to Nicolette.
All right, guys, why don't we get started by introducing our experts who will be here to answer any questions you may have. So feel free to shoot them in the Q&A as we're going along. We've got Brian Liu. He's an applications engineer with Meanwell USA. Chuck Stack, Director of Engineering and Marketing with Powersonic. And Kurt Padera, Director of Business Development, Battery Solutions Center, Sager Electronics. You can see them there on the screen, and they'll be our guests today. So why don't we get started by looking at the evolution of the battery market over the last few years. Chuck, maybe you could kick us off and tell us a little bit about how that's changed and evolved over time.
Yeah, thank you very much, Nicolette. I think the biggest evolution has been the emergence of the lithium-ion battery as a real dominant player in the market. So I did want to spend just a few minutes telling everybody a little bit about the history, because I actually think it's quite interesting. It started back in the early 70s, and it was actually Exxon that was doing some research on lithium metal batteries as an energy storage device. The gentleman doing that was named Goodenough. He left Exxon and went to Oxford and actually released a lithium metal battery in 1979. It was a lithium cobalt oxide battery. It was the very first battery based on the lithium metal that was rechargeable. The issue with this battery is that through cycling, the metal would actually grow dendrites, and that would short out the battery and cause some serious hazard safety issues. What happened then is they wanted to evolve to a more safer battery. So they started to impregnate various substrates with lithium ion. So they got away from the metal, but they still use lithium ions as the main source for the rechargeable battery. And 85 was the first working lithium ion battery. This battery then did not grow dendrites and was much safer than the previous ones. In 1991, Sony was the first company to actually release that battery into mass production. And that was really the boom of consumer electronics. So today, almost every consumer electronic device you buy has a lithium ion battery in it. And it all goes back to Sony in 1991. There's various lithium ions that you can actually make batteries out of. One of them is lithium iron phosphate. That one came about in 1996, and it was chosen mainly because it is even safer than the other lithium ions being used at the time. It's a little bit less reactive material and is very safe. In 2001, an NMC patent was released, which is really the battery that's used in hybrid vehicles and other EV vehicles. So in 1997, you started to see the lithium battery get into the automotive market with the Toyota Prius being released in 1997. The automotive market really took off and has really led to exponential growth since about 2008. And if you recall, that's when Tesla released its Roadster. So in 2008, lithium batteries really started to grow in volume of sales. And the Tesla Roadster to today has seen a big increase in the battery's capacity as it went from a 245-mile battery. It can now do over 370. In about 2010, the batteries started going into larger and more complex systems called energy storage devices. So these are the backup power for like windmills and big power plants. And in 2014, the largest lithium battery backup system at the time was released in San Diego. About 2015 is when Powersonic got into lithium batteries. We released our first two medical batteries that go into medical carts in 2015. And since that day, we have released another 50 batteries. So we have a broad suite of batteries. The emergence of the lithium battery and its importance in history was symbolized in 2019 when the very first inventors of the lithium cobalt oxide and the lithium ion were awarded the Nobel Prize. So Nicolette, I think the biggest change in the battery market has been the emergence of the lithium ion and what it's done to the marketplace.
You know, as we look backwards a little bit, why don't we look forward? So, you know, now we've kind of seen what the biggest changes, but what then should we be thinking about as we go forward? What types of trends should we expect?
Yeah, that's a very good question. Now, there's two things that I think you have to consider when we talk about the trends. One is the technology. So this is basically a technology play with the development of the lithium ion battery. This will continue. Three main things are going to be focused on, I think, in the near term. One is there's always a focus on the physical chemistry. And so what that means is the elements chosen and the size of the particles. What that does, it allows you to increase capacity within a given footprint. So I talked about Tesla. Well, they changed the mileage that you could get out of a roadster from 245 to over 370 miles per charge, basically by focusing on the chemistry. The other thing is that you'll see that there will be investment in trying to increase the charge rate even further. One of the things that holds a battery back is not the discharge, but how quickly can I charge and make it ready for use? So I think there's going to be a lot of focus on even making that faster and faster. The other thing on the technology is lithium does have some performance limitations at low temperatures. Today, most lithium operate reasonably well discharging down to -20°C. You're going to look to extend that to -40 or beyond, and that way it will work virtually any place on the planet. And there will also be a focus on improving its charge. Right now, most of your lithium ions don't accept a charge below freezing or 32°C. So technology is going to be a big play. But I think the rapid growth is going to be coming from the opportunities. Legislation and environment. On the environmental side, there is a lot of concern about global warming. That is going to drive legislation, which will drive adoption. General Motors just recently announced by 2035, all of their cars are going to be battery powered. The federal government just put a law in place that their entire fleet is going to be battery powered. In Las Vegas or Nevada, where I live, we just voted to say that 75% of our energy has to come from renewable sources. So that's going to be a big play in driving the opportunity to get the growth that I'm showing on this graph. And then there will be some geopolitical. Lithium today, lithium batteries are under a tariff that was enacted by the former administration. They're getting to be such an important part of our economy. I wouldn't be surprised to see that there's some geopolitical things that go on that kind of influences that growth too.
I know that was very comprehensive, but Kurt, did you want to add anything to that? I know. Did you want to talk a little bit about the evolution as well? I mean, Chuck did a great job there, but I was wondering if you wanted to piggyback on anything he said.
Yeah, the one thing that comes to mind is, the automotive industry is really driving the technology much faster than it ever has in the past, because every mile means another, more range for a vehicle. So there's a feverish pitch to try to get the most out of these battery systems as possible. And some of it's even done mechanically, meaning they're looking at making larger and larger sizes. Now that we have, we'll call it understanding the safety of the systems better. So there's a lot of things in play that will affect not only the automotive industry, but then that filters down into the high-tech industry as well. So we look forward to those advances for all the different applications we run into.
So then,
I just want to say that cross-pollination, Nicolette, is going to be one of the real benefits of the automotive really taking off. It's going to help all of our industries and all the way back down to the robots that are based on lithium as well.
Yeah, you mentioned robots. Is it going to also, does the autonomous vehicle and some of the stuff that's going in there also going to play a factor in the growth? With the buses, trucks, things like that?
It will. Right now, as this, what I'm showing here on this graph is kind of like the key players. So other markets that are actually going to grow as well. I mean, if you look at some of the advantages that lithium has to actually providing power so you can untether a vehicle, it actually is going to drive tremendous growth in all industries. I mean, it's almost unlimited what we're going to see as the technology evolves.
So we have a couple of questions coming in from the audience. Since we're talking about, lithium, let's address some of those. You know, with lithium being a limited resource and with the demand shown, where will all the lithium raw material come from? One of our attendees would love to know.
So I actually don't have the information readily available, but we can provide it when we send stuff out. But right now, the raw lithium material, I think there's reserves in like 4 or 5 different countries. And if I recall correctly, the largest reserves are actually outside of China, which produces the most batteries, and they might be in Australia. But what we're seeing is an increase of various countries in exploration to find more and more lithium. But yeah, it's now in like 4 or 5 countries.
I can add to that a little bit, Chuck. It's a matter of the simplicity to extract the lithium from different forms, meaning there's big deposits in South America, down in Peru and Chile. Like you said, Australia has large deposits. There's also large deposits in Nevada, but they're tied into the clay system there. And the problem is, how do you extract the lithium economically out of the core or ore material? And they're working on it, I know, feverishly over at Tesla, trying to figure out economic ways to be able to make and extract lithium cheaper and cheaper. So there's actually an abundance of the actual raw material, but it's a matter of getting to it and getting to it at the right cost.
On this topic, somebody in the audience was asking about the recycling of these batteries. Does that play a role in any of this as well? What factor does that play?
And I'll let the others chime in too. The recycling so far hasn't been as focused as, say, the effort of recycling around a lead acid battery. I mean, there's lots of channels in place for the recycling there. Typically for us, Nicolette, with our customer bases, we work with large recyclers in various states, and we set up a program locally with them. But I am seeing recycling becoming more and more of a focus. There's actually more technical white papers on recycling today than there was just 2 or 3 years ago.
Yeah, there's a big focus on that. Sorry.
No, go for it, Kurt.
No, there's a big focus on recycling and reusability, obviously, and reclaiming the materials in the product. And I think you'll see more legislation coming down the pipe here that'll make us go in that direction as well.
So then let me ask, there's a question here. So why has Powersonic then chosen to focus on lithium iron phosphate when there are so many other chemistries available?
Well, that's a really good question. So part of it is rooted in our history. So Powersonic, we're 50 years of a steel lead acid battery company, and we have lots of knowledge and applications around places that use lead acid batteries. At the core of it, lithium iron phosphate, with its voltage under full capacity being really close to 3 volts, is very good for replacing steel lead acid batteries, where most of those applications are multiples of 6 volts. So a 3-volt battery can be used to make a 6-volt, 12-volt, 24-volt. So the primary reason is it's just electrically very good for replacing steel lead acid batteries. But in addition to that, there is just many advantages that you get from using the lithium ion battery when you compare it to a steel lead acid. The power density is twice, the constant voltage during discharge. A lithium battery gives you constant power. It's much easier to design a circuit when you have constant power, and your devices never lose their performance as they start to discharge. Lithium, really, I call it the battery for cycling. It has 5 to 10 times the cycle life of lead acid batteries. So when you think about a rechargeable battery, the one thing you want to be able to do is use it for a long time. So the cycling capability is very high. So Nicolette, in a nutshell, those are the main reasons, but it really has worked out very well for us in the applications we've gone at.
So Brian, let's switch gears a little bit and talk a little bit about battery chargers. I would like to touch on, automation in a moment and, talk about some of the advancements and how they loop in, but why don't we talk about some of the battery chargers that Meanwell's got going on over there?
Okay, yeah, so for Meanwell, I mean, we are 39 years company. We do power supply mainly, and then we also have the charger line. We do a lot of 3-stage charger legacy product for lead acid battery because it was so popular in the past. And but we are moving toward the lithium-ion battery. Just redesigning our product and doing new product that can do like 2-stage charging for lithium-ion battery. Because usually that's what how to charge the battery, and we see it going. I mean, our sales number coming up, telling us lithium-ion battery charger are going, and the market are there is better. And so we have various types. We have like external, like like a laptop charger you plug and play, and then we have hazardous environment lab battery charger where some customer is integrate into something that mobile like automation. So usually they some component fall off if you don't encapsulate the power supply. And also one of the unique line that we're trying to do is we are doing a programmable charger, meaning that the customer have ability to program the charger whether you want to use it for lead acid or for lithium-ion battery. You can program the voltage, you can program the current, you can program the power. So basically, it's one for you to use either battery, lithium-ion or lead acid battery.
So this is going to weave in nicely. Let's talk a little bit about automation. So Chuck and Kurt, we talked about the history and the trends. Now, how have all of these advancements enabled higher levels of automation? What would you consider then a significant battery advancement over the last decade that has kind of enabled these automation strides? Want to take that one, Chuck?
Yeah,
Okay, I'll start, and Kurt will chime in.
Okay.
Well, I honestly, Nicolette, I think some of the things we talked about, the capacity and the cycle life, it's coming down to that a battery no longer has to be just used when it's purely a remote application. I mean, they last so long in terms of cycle life. You might put a battery in now where it's only going to be unplugged for a few minutes. I mean, it gives you such options now because the battery is so robust and has such a high capacity. So I think it just up the playing field for anybody in automation to take a machine that might have been solely stationary in the past and now make it a little bit more mobile. I think it really has advanced that far that as a power source, the battery is completely reliable and you can change how you do things. And it's really due to the lithium ion. Its capacity, its cycle life, all those things allow the designer of any equipment to consider new options.
And to add to that, Chuck, as the technology continues to evolve, look at power tools, for an example. You can practically get any power tool today in a portable format. And that's because the technology continues to allow you to charge faster. It's more energy dense, so you can carry more power in a smaller area. And it's safer than it was 10 years ago as we continue to learn about how the materials react. Do we use different separator materials and so on? So it's really opening up the doors to more and more applications and creativity because now there is this large amount of power in a smaller and smaller space.
Yeah, I think, I mean, it's lighter too. I mean, you put it in the automation, that car going to go around like an iRobot going around your house. So with the lithium-ion battery, it's lighter. So it makes sense to use lithium-ion battery. It lasts longer, if charging faster. Lunchtime you come back and charge them and then use it after lunch.
Yeah.
So that usually.
Well, Brian, what about the battery charger? So how, what role does the battery charger play in all of the automation that's going on today?
depend how the designer is gonna design the card. Like for example, we're talking about the forklift, for example. You know, those are battery built in, and now people use lithium-ion battery. And for the charger, usually they are just installed in one location, like a charging dock. And then, you know, that car gonna come back there and then go charge it. And then after about a couple hours or 1 hour, and then he leave the station and then he go again. It's just exactly how the iRobot play out. But, you know, charger is gonna be higher power to charge, and then because you have bigger battery there.
Then what do you think engineers should really be thinking about when they're selecting a charging option? And this is actually this actually ties in nicely to one of our audience questions about how to get those chargers and batteries to really match each other, how to find that best match.
Yeah, I mean, there are multiple factors. One of them is, you know, how many mAh, what is the mAh of battery you are doing in designing. And then from the mAh battery, for example, Powersonic lithium-ion battery, usually recommend is like 0.5 to 1 C charge. So you have to take into consideration, okay, I'm using 100 mAh. So my charger, so let's say my charger is going to be like 50 amp to charge, or do I use 80 amp to charge? And from there, you find out the charging current you need, and then the voltage that you need to select the charger for it. And then also installation, where are you going to install the charging dock at? Like if you will install outdoor, then you have to go something like, you know, fanless, like no fan charger, because, you know, dust, moisture outdoor is not really good. So, and then if it's indoor, then inside warehouse, so you should be okay.
Do you think we're going to see more and more outdoor charging stations with a ton, you know, with vehicles, with the electric vehicles?
Yeah,
that's
I mean,
more of an issue.
Yeah, golf cart is more kind of outdoor, and some even build the charger into the car. So like just like an AC cable, they just plug in an outlet and charge, or they have a charging dock. That then is going to become outdoor. The golf cars come back, you charge him, and then that station is outdoor. So encapsulated charger is what Minwell have, and it's getting more popular now because people don't want to deal with the fan or moisture or dust failure. They keep replacing the charger. It's not a good idea.
I heard correctly, they were talking about marrying the charger and the battery. And I just want to chime in a little bit on that, because cell selection is critical to make sure that we match the proper cell to the charge and discharge rates that you're trying to accomplish. Like anything, there's trade-offs. So if we give you a cell that can charge and discharge very quickly, let's say in an hour or less, you're going to sacrifice some capacity or runtime. Hence, on the other side of the coin, if you want something that's going to run for 10 or 12 hours and you don't care about charge time, we can put a cell in place that has more storage capacity, meaning it has a higher energy density versus something that's going to go really fast. So there's choices that we have to make up front to make sure you get the best best cell to marry up with the charging system, and of course meets the application goals.
And there's another thing that I want to add on to what Kurt was talking about. With a lot of the batteries that you buy, inside the battery, it's going to have a PC board that actually has protective circuits and things like that on it. So one of the things you have to consider is, as Brian was saying, you have a charge current that comes in. Well, the battery might protect if that current's too high, and it will protect voltages too. So the other thing to consider is just read the specs of the battery to see if it has any information in there about current limits it might have, voltage limits, all those sorts of things. So almost all your battery specs will tell you that.
So
yeah, I think that's, go ahead.
No, go ahead, Brian.
No, yeah, I'm saying that is very a smart way to do it, because I have customer calling in and asking me, hey, can you suggest me a charger? I say, I cannot suggest you a charger. You don't know what mAh of the battery. It's going to damage after 2 days. And then you don't call me back, say, hey man, the charger, the battery is gone. So that's why you have to really look into the battery spec, and, you know, or you send to me, we talk about it, and then, you know.
Mm-hmm. Yeah. So one of the attendees is asking, for systems which stay plugged in most of the time, how do you maximize battery life? 100% charge every time. float charge at 70%.
We were talking about this before this call, right? We were talking
Yeah.
about charging.
Yeah.
So I'll start and like respond as well. So one of the things about charger history is a lot of your chargers were designed for lead acid batteries. A lead acid battery discharges at such a high rate that you usually keep it on a float or a trickle charge to maintain it to be ready. Okay. So you got kind of a legacy there of chargers. Lithium batteries, on the other hand, very low discharge rate. So if they sit on the shelf, you don't have to do anything to maintain them. They'll be ready when you call on it. As it turns out, it's actually best for a lithium battery if you don't keep it fully charged. I mean, if you're going to store it for a long period of time, it's better if it's not 100%. And it does not need a trickle charge. Your battery is going to protect itself from being damaged by overcharging, but for the life of the battery, you're actually better off not keeping it connected to that charger. Or a lot of your lithium chargers today, they'll sense when it's fully charged and it just shuts itself off. It doesn't maintain it. So hopefully I answered the question, but it's really trying to keep the battery. You don't have to keep it charged or on a charger to maintain it. And it's best if you don't.
Did anybody else want to add anything to that?
No, I don't.
Well said, Chuck.
Chuck, you got it. All right. So we have another question from the audience. Let's take this one. For lithium-ion batteries that have a protection circuit, is series cell balancing managed by the PCB as well?
So if they have a protection circuit, they may interact. I mean, a battery in a series that hits one of its protection limits, it will react to it. So it might interrupt the charging of the whole system. It depends on the battery. That's why you have to read the protections that the battery has. Some of them will allow the current to go through the battery and won't disrupt it that much. For batteries that are charged in parallel, the batteries tend to try to balance each other out. So the protection circuit, although it can be tripped, oftentimes it really doesn't get tripped because the batteries tend to balance each other out as they're being charged and discharged.
So I'd like to talk a little bit about the battery features and charging options that support automated guided vehicle applications. If we want to maybe talk a little bit about that for the audience. Sorry, Chuck, do you want to talk a little bit about this? I know you probably do. So I'll start with you.
So Nicolette, one of the things I think the audience that are designing automated vehicles need to understand is that the companies that they're working with, like us at Powersonic or Meanwell, we actually got a lot of technologies in our products too that they can take advantage of. So one of the things about unleashing power is our batteries, the ones that have communication. So we have a series of Bluetooth batteries and we have some that have a RS-485 port. There's information in there that the automated vehicle guys might want to have access to. So I could be designing a robot, and instead of having to design a Bluetooth application to tell me how charged it is, they could buy a battery that has a Bluetooth application already in it. If they want to design a robot, they want to make sure that they extend the warranty life. You buy something with communication, the battery is going to keep track of the number of cycles it's seen. There's information there that can actually unleash more products that they could have. So that's one of the things people need to be cognizant of is the technology that they're putting into their robots. They're expanding the information they have as well.
Brian, is there anything you'd like to add to that?
So Chuck, for the Bluetooth is actually telling us how many cycles the battery has been charged and what is the charging voltage and current that is being charged to the battery and like the percentage?
Yes, yeah. So it's a very simple app, but it'll tell you how many cycles it has seen. If you come up to a battery with our Bluetooth on it, and it's like at 0 voltage or exhibiting some sort of protection, it would actually tell you if it's in a protected mode. And then it also tells you about the individual cells. It will tell you voltages and currents at the cell level, so you can see how balanced the battery is. So it
Oh, okay.
has that kind of information readily available.
Okay. Yeah,
Yeah.
I never seen a battery with a Bluetooth function.
Mhm.
It's interesting.
Yeah, and all the information starts with a smart IC that collects all the information from the battery. The Bluetooth is the great medium that then delivers it to the host or the charger, just to try to clarify.
Yep.
That's pretty cool because as devices get smarter and smarter and they're communicating more and more with the battery, you're increasing the life of the battery, you know, because it knows when it needs to shut down, when it needs to charge, when it needs all that information that's coming out of it.
Yeah, you know, I think if you just think of combining the robot functionality with things that we've talked about, I mean, you could program into your robot a reading to tell it when it needs to be charged.
Right.
You could program into it where Brian's charger's at, and it could go charge itself. I mean, it really gets to the point that's almost autonomous. So there's a lot of things that I think we'll see grow in the coming years about smartness of all devices.
And I'm assuming you're going to see the same thing, even though, you know, robots are same as autonomous cars, but you're going to see the same thing in automotives. They're going to go, oh, I need to charge myself and, you know, move to the place where they can.
We have a question from the audience. Is there a chip in the battery package that remembers the state of charge?
There is, and Nicolette, this gives me an opportunity to talk about a little thing, another aspect your audience should hear about is batteries when they protect themselves. There's actually a couple of different levels of protection for a lithium battery. The simplest protection is called a balanced circuit, and generally all that does is it ensures while it's charging, the cells get balanced, so it optimizes the battery for its discharge. The next level of protection is called a PCM, a protective circuit module. What that does is in hardware, it protects for currents, voltages, et cetera, that could damage the battery. Above that is what's called a BMS, a battery management system. That does then have a smart chip. And the smartness of that chip can vary. But it's the device that collects the history that tells you what's going on. So you need to have a device that has that in it. And if you have that, you can communicate that information out.
Okay, so we were talking about automation, and you know, one of the things I wanted to bring up was kind of speed, right? So let's say we've got a golf cart or a robot, and an end user wants to charge that faster. How can we do that? Can we do that, Brian?
Sure. Yeah. Yes. I mean, with the best way, if you really want to charge it faster, to use a higher charger power. So for example, I mean, if you want you're going to use a 100 mAh battery and you want to charge it fast, just use a 100 amp charger to charge it faster. But it's really not really recommend, because if you do that, you're gonna shorten the lifetime of the battery. So usually 0.5 or 0.8 is the best way to do it, and to keep the battery lifetime at its best. So
it's where it's important for us to know that kind of thing up front when we're designing the circuitry for a battery and understand what the cell's capabilities are. So if you wanted to, let's say, charge at 100 amps in your golf cart, Brian, you know, we have to make sure the circuitry matches that kind of power requirement, so you don't have any issues with the electronics and so on that protect the battery. So that we all have to work together on that when you want to do things like that, like increasing the charge rate of a product.
I wanted to chime in. One of the things I learned today that I didn't know Brian's team had a programmable charger. That sounds like a really slick way for people that are just trying to figure out, you know, they're breadboarding a device to get all the tools that they need to play around and figure out how charge rates and stuff. That sounds like a really interesting product.
Yeah, I mean, it's the designer who designed the golf cart, for example, they have to think about how much weight is the cart carrying. I mean, and then how long is your battery should last in 4 hours? Like, what is the runtime? and how the 100 amp-hour can carry how much weight for it to do work, and then you come back. Then you select the battery, and then we have a charger. When you program it, you want to be faster, you just hit the button and then it's going to go faster. And we also have the PM bus, what we call power management bus in the charger as well, where you can also do the programming as well. It's basically it's a complicated system that the engineering have to evaluate. It's not just Powersonic, not just Minwell or Kurt. I mean, all three of us had to be like digging in, asking questions: how long you want it to be running, how fast do you want it to be charged in 1 hour? Then we can figure out all the number and help out the customer.
Yeah.
So this is one of those situations where a custom solution might work as well, Kurt?
Yeah, especially when you get to, of course, there's a certain amount of standard products that are out there, and Powersonic has a very nice line of standard products that they offer for applications like golf carts. But there's times you run into situations where you have either a specific geometry or you have electrical requirements that a standard just isn't going to meet. That's when you get into custom type assembly work. And one nice thing about custom assemblies is that allows us to choose a cell and electronics that exactly meet best with this given application, versus trying to maybe take a standard that's maybe not quite optimized for exactly what you're trying to do. But of course, there's trade-offs there. Obviously, off the shelf versus something that's custom. There's a lot of work that goes into a custom design, and to make sure it's done right and mates properly with your charging systems and so on and so forth. So there's a place for customs out there, and that's what we do. We see it all the time. But there's also, if there's an application where you can use a standard product that let's say Powersonic and Meanwhile has to offer, we actually try to guide them down that direction or that path first before looking at a custom solution.
So I do want to talk about creativity a little bit in a moment, but we have some questions coming in from the audience, and I think safety is important as well to talk about. I know someone has brought up, the possibility of batteries catching fire, or preventing these kinds of things from happening. Are there any safety considerations we should be thinking about?
So I was going to talk about our batteries, and I think Kurt's experience with custom solutions and what they do to prevent it definitely is worth having the conversation on. So about batteries catching fire, I talked a little bit about history. I mean, the lithium metal batteries, definitely, they had a propensity to short themselves. And so that's why we went with lithium ion. The lithium ion, then, if there's no manufacturing defects, generally there's nothing within it that's going to cause it to catch fire. So then the question comes down, is there anything I have to worry about externally? Could I do something externally to the battery that could be a hazard? Well, most of the batteries have protections within them that sense what's going on outside of them and prevent that from causing a problem. So the biggest issue generally would be is if you shorted it. So if you short the terminals, that means you've got a whole bunch of energy going to be released really quickly. The batteries have protective circuits to allow that to not damage anything. And then the other thing I would like people to know is that there are lots of regulations out there that you have to be compliant to that generally ensure the battery's safe. So you got UL regulations, IEC regulations. You can't ship lithium batteries unless you meet certain testing standards. So the vast majority of it, the batteries are very safe, and they tend to have designs that protect them from external events.
Yeah, and to further to that, Chuck, is there's, like you said, there's safety built in, and I'm going to talk about a little bit about high energy lithium now, like that you're going to find in your Teslas and so on. They have current interrupt devices built into the cell, such that if it does have an adverse condition or it overheats or is overcharged, there's an interrupt device that opens the cell and won't allow it to get into a condition where it potentially can go into what we call thermal runaway. Those are those fires that you see when there's a big problem with lithium.
Right.
When we design a custom system also, especially when you're using high energy lithium, the nice thing about the Powersonic solution using what's called lithium iron phosphate is it's a much more stable chemistry. such that it's very rare that you're ever going to have a safety issue unless you really, really try to abuse that product. Versus high energy lithium, which volatile is probably not the right term, but it definitely is more susceptible to going into thermal runaway because there's much more energy present, and the thermal runaway threshold temperature is much lower than iron phosphate. So when we design a battery system, safety is the number one thing we always look at up front, such that if, let's say, you do have a problem and somebody does cause an issue with your battery and one of the cells does go off, and I have a cell cluster of, let's say, 12 cells, I want to make sure that I isolate that one cell from not propagating its energy to the next cell, to the next cell, to the next cell, and causing a chain reaction. So that's one of the major things we look at when we're designing a pack. The second things are when that cell goes off, where is it going to vent into? We don't want it to vent into something that's going to create a bigger problem, something that's flammable. So we're always looking at the design, the product, and how it's going to interface, just in case that rare occurrence does happen. What do we do, and how can we make sure it doesn't become a big problem? So I could go on for a while on this topic, but there's a lot of things we look at and consider when safety is involved.
Yeah, I mean, for us, we also have customer asking us, what if my battery damaged? What your charger going to do to it? And basically, our charger is, so from there we kind of take into the our new product we designed so that when the charger detect the battery voltage is too low, it won't charge anymore. Yeah. So they don't want a cause hazard. So when it's too low, the charger say, oh, this battery is no good. I'm not going to charge it. I'm not going to overcurrent it. And that's what it. And we also have and we also have the thermistor where you can attach to the battery, and if it gets too hot, it's going to reduce the charging current itself, so to further damaging the battery.
And that's where you and I working together on these solutions, thermal management, current management, and even the battery itself will tell you that, hey, I've got a problem here, don't charge me. You know, those systems are there such that we can protect the system from going into a situation that's going to be problematic.
Thank you guys for addressing those concerns. That was helpful. But we do talk about creativity in the title of this chat. So I would like to go there for a moment. You know, when we were all talking prior to this, we were talking about all the really cool applications that are out there right now that are super creative. And I think what I'd like to do is talk about the products that are available that are really unleashing that creativity in the industry. So, you know, what's making that really happen? What's driving that? Who'd like to kick us off?
I can start.
Okay.
So one of the things that we talked about when we talked about the history is that basically the explosion of the availability of lithium ion battery products. So one of the things I'd say is that just the sheer number of products that are available and the capacities that they have today versus 5 years ago is probably an order of magnitude different. For us at Powersonic, we've got batteries that can be used as a starter battery. So basically they'll start small engines like motorcycles. We got batteries that are big enough that could power probably a robot for a couple of days without ever having to be charged. We got batteries that can be put in series and parallel. So it's just the sheer number. So I think part of it, Nicolette, is you got flexibility. You've got options now. And I think part of that, what that drives then, it can be a little bit daunting. That is why you call people up like myself or Kurt when you have an application. You talk over what you're trying to do. And more than likely, we have something that will help you get there. But it's because we got such a breadth now that we never had, that we could virtually solve almost any problem that comes up. And if we can't, we give them to custom people like Kurt, who definitely.
Yeah, I mean, with the expansion, like you said, Chuck, the expansion of the market and more players manufacturing lithium materials, everybody's got a little different recipe or a little different product that fits best in a certain application. So it's I don't want to say it's limitless, but there's a product almost for everything out there today with the technology, the way it's expanded out, where, you know, at one point in time, we were limited only a certain number of sizes of cells. I mean, there's things out there today where you can, let's say lithium polymer, for example, you can design a cell to fit into in a precise space and tool one for relatively low cost. So there's things we can do today that we couldn't do 20, 25 years ago to customize things for specific applications, which in some cases creates the ability to have things like the a Fitbit, for example, where you got a real small, tiny rechargeable battery and things like that that have opened up the marketplace for those types of products.
The one thing that we haven't talked about too, Nicolette, that's I think the audience should know, is that we talked a lot about chemistries, but within the chemistry, you actually have different types of cells. So two classic ones, you have what's called an energy cell and what's called a power cell. And then what differ in is the ability for them to discharge at what rate. So an energy cell is really designed for most of your cyclic applications where you want it to run for 10, 15 hours. So it has a discharge rate that is about 3 to 5 times the rated capacity. A power cell is to generate a lot of power quickly. So it will discharge at about 30 times the capacity. So like your power tools and stuff like that are going to be using power cells, where energy cells would be in a cart that has to move for a long period of time. As Kurt said, in between, there's a whole bunch of boutique chemistries. I mean, I could give you a cell that is rated for 10C. It's neither an energy or power, but if you have an application for it, we can do it. And that really unleashes your creativity. It can be really a cell designed for you.
So it's more like a cranking power, where where you start up the car, that's called a power cell. Then if you car running it, they call energy cell.
Right.
Okay. So I think more of the customer would use energy cell than a power cell. It's more benefit for them just to have it running around, like for automation, they going around, they just power up the motor. It's not to be cranking any more power.
The starter batteries tend to be more of the power cells. So you're right. And then energy cells is a lot of what are in our batteries, because they go into cyclic applications where it's going to run multiple hours. So you're right. It's the split.
We have a question from the audience here, a very future looking question about battery powered airliners. Is that something that anybody foresees in the near future? And my question is, how do you charge that? How do you charge an airplane?
Right.
Well, they do it with drones now, right?
Well, yeah.
Commercial
Actually,
aircraft.
it's doable if you use fuel to charge the battery if you're running out of battery.
Yeah. I mean, anything is possible, right? But it would be a matter of cost, and how you would manage a system that could produce that kind of power would be, that's beyond my understanding of how to manage that type of energy. But I mean, theoretically, you could build a battery big enough to do it.
Right.
In theory,
we're gonna have to go with personal aircraft first.
Yeah.
Okay.
Well, personally, I think it's inevitable. As we go to more battery powered solutions, it will be a day where gasoline is actually in diesel fuel. Those are things that are going to be expensive to produce because it's not being used anymore. So, I mean, it's inevitable. Who knows when, but it has to happen.
Yeah. And then after airplanes, we got going into space, going to Mars.
Absolutely.
It's the limit. Yeah.
So actually, we have a quick question here for Powersonic. There's a specific size that somebody's asking about. Is the 18650 size the primary cylindrical footprint size that Powersonic will be promoting lithium phosphate cells in?
Yeah, that is an interesting question. So the 18650 is I think it's still the most common size. So if you're buying a cylindrical cell, the 18650 more than likely is what you're going to be buying. In our products and in the cells that we sell by themselves, we actually do have 18650s and then 26650s, and we have prismatic cells. It really depends on what you're trying to do. We generally use prismatic cells for some of our larger batteries because they just fit better in a case. I think putting squares in a square case is probably a little bit easier than putting round things in a square case. So that's kind of why we do that. But it really comes down to what you're trying to do. For us, the 2650 is actually going to be a little bit more popular, but we do have the other cell sizes.
Thank you. We have another cool question actually about wireless chargers. And Brian, I know you, Brian with a Y, I know you love this talk. So,
I do. Especially things that move. Charging things wirelessly that are moving is a big thing.
So we've got wireless chargers for phones, right? So are there similar chargers for robots and vehicles? And, so what does the future of that look like charging wise? Maybe Brian with an I, you want to take that?
Yeah, I seen it. I seen it at Pocket Mall where it's, of course you need to have a charger with the output voltage and current, and then but they basically have a coil like connect to the charger output and winding it and lay it down to the floor, so it become like a charging mat. So and when the robot come back, just like on the mat, it's automatic charging the battery in there. So they do have that technology now, but the charging rate is kind of slow, and it had a magnetic field that generated pretty high, that had to be considered. So wireless charging is there. I seen Tesla doing it as well.
Right. Do you
for their car, not for the vehicle that they're selling, but for
right.
the internal use.
Right. So do you think it's also going to be like right now, a lot of times things have to have contact, right? Like a phone charger, it has to have contact. What about when it doesn't have contact, right? There's some, there's some things that where they're working on charging where it's completely, there's space between the two items that are being charged. Like say, for instance, the car where, it's going to pull up and there'll be some distance. Do you think that's going to be coming into play where you have true wireless charging from a distance?
Yes, it should be. I believe the technology is there. I mean, you just drive your car in that particular location where you have to stop. It's just like a car wash. So the red light, you just stop there, and then it's going to charge you.
So that's where the robotics are going to come into play. It's going to drive itself in and park itself.
Yeah, it is there.
Yeah.
Well, thanks, Brian. I'm glad we had some fun with that.
You do.
So I have a question here. So we talked about creativity. We've got a lot of fun stuff coming in from the audience. We talked about creativity. Why don't we talk about lithium iron phosphate in relation to creativity and the role that they're playing, these batteries are playing in the industry and how useful they are. Chuck, do you want to start this?
Yep. If you want me to start,
I'll let you start this.
Okay.
Time.
It's nice.
Very eager, so I'm gonna let you go.
I don't want to step on anybody.
All right, go ahead.
One really nice thing, because lithium iron phosphate is a much more stable system, you can make much larger packages out of it safely than you can with what I call high energy lithium, such that high energy lithium, like what they use in the Tesla, there's a very advanced monitoring system that they use to make sure that those cells are all kept at an even temperature, that they're all balanced properly. It's a very, very technical system that is used there. Nice thing about phosphate is because it's more forgiving, you can make these larger systems and not have to have the constraints of the safety that you have to worry about with high energy systems. So golf carts, for example, or medical carts are great applications for phosphate, because again, you can, especially if you're using prismatic modules, it's a nice, safe, reliable, long-lasting energy source. Chuck, you want to take it from there?
Well, the only thing I would add, what Brian's saying is that you can unleash your creativity without worrying about hurting yourself. So that's always a good thing. But the other thing I would say too is if you look out there, in addition to our technologies, you can find stuff if you're building stuff with cells, that there's lots of technologies on BMSs that you can buy, lots of things you can piece together on your own. So I think as the technology has evolved for batteries, for chargers, for custom solutions, there's lots of things that you can find on your own. And if you work with one of us, we'll help you provide some of the building blocks. So there's lots of things you can do to really unleash your own creativity. And the market, as it continues to grow, more and more are going to be available tomorrow than there are today.
So why don't we have about a couple minutes left. Let's talk about design considerations for using Powersonic batteries in series or parallel. And then I have a question I want to ask everybody. Go for it.
Okay, so I'll just chime in first. On the design considerations, the main thing to remember is a lithium battery has a circuit board in it, and so it has protections. And so as far as design considerations, you need to know that that's going to influence the number that you can put in series and parallel. So all of our specifications tell you exactly how many can be put in series and parallel. Other than that, they're going to behave when you charge and discharge them like a lead acid battery. So if it's a 24-volt battery, you need a 24-volt charger. But the main thing is it does have a circuit board. Read our documentation on the protections and make sure you understand what's going on there. Okay.
Awesome. So we are coming up to the top of the hour, and there were a lot of questions that we did not get to, but don't worry, guys. You know, all of our experts will follow up with you after, and you will get some responses. So we promise to get to them. But lastly, why don't we talk about what additional resources are available from all three of you guys, Powersonic, Meanwell, Sager. You know, where can the engineers come to find some more information? Are there any resources that you really want to point everyone to?
I can go first. I think we've developed a very functional website that has a lot of product information. One of the things that I've been particularly pleased with on the marketing side is we've released a lot of blogs that are just aimed at being educational. And I find those are a really good place to start, is read a few of the blogs, get up to speed on what the technology is all about, and then just go from there.
I mean, yeah, go ahead.
Go ahead, Brian.
Okay, so for us, I mean, we have charger from 30 watt up to 3200 watt, and they are really programmable. It's suitable for all kind of battery, and our, you know, to hit us up, and then we let you know the charger that is suitable. But you know, like Josh say, you got to look into the spec of the battery. Don't just say charging battery. It's no good. And you know, and we're working with Kurt. I mean, when Kurt say, you know, I need this charger, this voltage, this current, then you know, meanwhile we have a solution for it.
Mm-hmm. And I can tell you from the custom side, there's so many options. It's very difficult to come up with a specific set of guidelines that's going to answer all the questions. What we do is we do have a system where we have to answer all the basic questions so that we know the application to a certain point. But really what it comes down to is getting all the details down to the nitty-gritty details and getting those correct. And that really is the conversation between the client and ourselves and Brian and Chuck to make sure that we understand exactly how you're going to use that system and then marry it to the proper components, cells, plastics. And again, there's a lot of decisions that need to be made, and it's difficult to give you just one resource that answers all those questions. That's why we say, please call us first before jumping into a new design.
Well, thank you everyone for joining us today for this live chat. I would like to thank our experts. Thank you guys so much for being here. And thanks to all the sponsors, Sager Electronics, Meanwell, Powersonic. And remember guys, speaking about resources, we are going to send out a resource guide to all the attendees of this live chat. Thank you very much for joining us, everyone. And thank you, experts.